completing the square means that we are going to take the equation that we are given, and we are going to rewrite it in a way that we can have a perfect square, something squared equal to a number, take the square root of both sides and solve. Okay. Now the first step in this process is just looking at solving some equations by finding square roots. So what's the solution of each equation? So we are looking at equations that have an x squared in them, but it's not like there's an x in them as well. So we can just treat this like we would treat any equation. We're trying to get the x by itself. So what is our first step in getting x by itself? And 4x squared plus 10 equals 46. Subtract 10 from each side, so then we have 4x squared equals 46 minus 10 is 36. Then what? Divide by 4. So x squared equals 9. How do we undo something being squared? We take the square root. So we take the square root. Now when you take the square root, we have to do positive and negative. So x would equal positive square root of 9. What's the square root of 9? 3. So positive 3 or negative 3, which we can write like that. Or if you want to write 3 comma negative 3, that would be okay as well. When we take a square root, you always put in a positive or negative. Yes. 3x squared minus 5 equals 25. So we are just trying to isolate the x squared, so we add 5 to both sides to begin with. Make sure you add 5 to both sides to begin with. Divide by 3. So we get x squared equals 10. Square root, square root. Now, what are we going to do with that? I do not want you to give me some random decimal answer. Nope, 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 nope. Now, in this case, you will leave it as positive or negative square root of 10. So if we break 10 down into its factors, we get 2 and 5. Neither 2 nor 5 are a perfect square. So we cannot simplify the square root of 10 any farther than that. Okay. However, what if we had something like so when we simplify square roots, and this is going to be true for square roots or cube roots or fourth roots, which we're not going to get into probably until next year. But when you are looking at potentially simplifying a square root, you are looking for perfect squares that are factors of the number. Now, some of you might be able to look at 50 and go, oh, hey, that's 25 times 2. 25 is a perfect square. Square root of 25 is 5, and you can go. Okay? I'm going to introduce it a slightly different way than that. If you can recognize this as 25 and 2 and just go quick, that's great. You can do that. You don't have to do this whole thing. But some numbers are going to be more obvious than others. So if you're unsure what to do with the square root, we are not going to get decimals or fractions. There might be fractions involved, but that's another story. I want you to do a factor tree. So give me two numbers that multiply to 50. 5 and 10. 5 is a prime number, so we don't have to worry about him anymore. 10 is not. What multiplies to 10? 5 and 2. So that is broken down all the way. That is the factor tree for 50. Okay. What we're looking for is numbers that we can take the square root of. Numbers that we can take the square root of are going to have repeated factors. So if you are trying to simplify a square root, this is how I do it. Inside the square root is the singles club. Okay? Singles club. Singles only. If you realize that you have a matching partner in the singles club, you have to leave because you are no longer single, you are a couple. Couples go out, singles stay in. So there are a couple of 5s. Since there are one pair of 5s, one 5 goes out front. Any singles that are left over stay inside. So the square root of 50 would simplify to 5 times the square root of 2. Now, how can you test to see if you are correct? Because we pulled out a 5, we essentially took the square root of a number to get 5. What is 5 squared? 25. 5 times 5 is 25. 25 times 2 is what we started with. So B, break it down. Break down 200 as much as you can. And your factor trees might look different than somebody else's, but at the end, you should end up with the same number of 2s or the same number of 3s or the same number of 5s or whatever might be involved. Yes. Would it put 4 in there? Okay, so let me just see what we got here. Oh, yes. Yeah. Wait. No, that's not right. You already broke 4 down, so that can't be right. So you have a pair of 5s and a pair of 2s. So this 2 is actually on its own. So a 2 would go in here, and then 5 and a pair. So only if it has double. And once you use that, like once you couple 2 of them up, they can't be coupled with any other. So if you have 3, one's going to be left alone. So if you like this, 2, and then square root 2. Well, what about these right here? Also, you just do times 5. Okay. And then square root 2. Yep. So if we break down 200, give me 2 numbers that multiply to 200. 20 and 10, sure. There are many options at that point. What does 20 break down to? 5 and 4, I would believe. 10 breaks down to 5 and 2. So I have a pair of 5s. But 4 can still continue to break down. So I have a pair of 2s. Now, I cannot pair these 2s with this 2. We only take 2 at a time. If there are 15 of them, 14 of them will pair up, and you will still have a loner left behind. So we had a pair of 5s, a pair of 2's, and a 2 left over. So I would write this as 10 times the square root of 2. And again, you can check it because what would 10 squared be? 10 times 10 is 100 times 2 would be 200, which is what we started with. All right, how would we break down 27? What does 27 break down to? 9 and 3. 3 is broken down as much as it can be, but 9 can be broken down to 3 and 3. So pick one of the, or some pair of 3s. Pick 2 of them to go together. And we have a loner. So what are we going to write for the answer? 3, because that comes out front, times the square root of what's left over, which is 3. Okay?